When we look at the diagram for this problem, we have a ball that has the same mass as the other ball. They both have the same velocity, and they're both coming in at the same angle, which means that the component of x velocity, Vx, and the component of x velocity here will add up to our mvx in this direction. In other words, the momentum x component and the momentum x component here add up to the momentum x component here. But the y components are opposite, and they're equal because the angles, masses, and velocities are equal. So the y direction momentum cancels out and is equal to 0. So all we have to do is figure out the velocity from an x equation. So let's look at the x component of the first one, m naught v naught cosine 60, and we could just multiply this by 2 because it's the same for the second one. So that gives us 2mv naught for our x momentum. Now we know that the momentum after has to equal the momentum initial. So to find our momentum initial, we have 1/2 mv naught because of our cos 60 and our cos 60. So that's where we get this 2mv naught from. Solving for vf, we just divide through and cancel out our m naughts, and we get the final velocity is equal to v naught over 2. This question is basically a definition. So it says if one knows only the constant resultant force and the time, so we're talking about F and T, what does that tell us? Well, that tells us the change in momentum. So A. In this question, we have two balls that get in a collision, and the first ball cruises off at some angle here at 6 meters per second. So we know that ball B must be heading off in the other direction. We just haven't been given any other information about it. So what can we do? Well, we can look at the momentum in the y direction because we know that the momentum in the y direction starts out as 0. There's no y component to velocity, so there's no y component to momentum. So to set this up, I said this would be the y direction, that the initial y component would be 0. So after the collision, we have m naught v final sine 53, so that's the x ball. And the second one is going to be m naught v final sine theta, and we don't know either of these. So we're going to have an m naught on both sides when we add that over, so we can cancel these out. And that enables us to get 6 times sine 53 equals v final sine theta. So we have two unknowns. So we can't do this and solve for either one of these, but we know that the combined VF sine theta has to be equal to 4.8. And the only choice in here that gives us 4.8 is 8 times sine of 37. So our answer is D. In this one, we have an X collision. So we have block M traveling at V and double the mass traveling at half the velocity. And the question is, what's the final velocity if they stick together? So we start out with mv colliding into 2mv over 2. So this is our initial momentum. And after the collision, they stick together and act as 3m times vf. So just solving for vf, we get 2/3 v initial, or whatever that v they called. Now in this problem, unfortunately, I think when this problem got copied, that the scale of this got thrown off a little bit. But you can still end up getting the right answer. Because if this is the momentum initial, the momentum final has to be equal to this momentum initial. This and this has to be equal. But this is 0, so it's not that one. These two added up would create a very long vector, and that also can't be equal to our initial vector. And in this one, we end up with a net vector to the left, so it can't be that. And if we do our parallelogram method, on this one we end up with a momentum vector that's down and to the right. But if we do our parallelogram method here, we end up with a momentum vector to the right that is very close to the momentum vector here. And like I said, if this diagram was properly to scale, this should have been a little longer and this a little longer to get a momentum vector out to here. But you can see it's close enough. So the answer is D, or E, the last one. Here we have a ball that comes in and collides with the floor and bounces off. Remember that a normal force acts perpendicular to the surface, so the floor is only able to push on the ball in the y direction. So what's the direction of that force that's exerting the impulse? That's going to be the force normal, which is going to be up, choice E. In this one, we have two pucks that are traveling along in an x-plane and a y-plane. And they're going to collide, and what they ask us is, what's the total momentum of the two pucks system after the collision? Well, if they're asking for it after the collision, it has to be equal to the momentum before the collision. So what's the momentum before the collision? We have to break it up into x and y. So our x momentum is just going to be the first block, which is 2 times 1.5, which is 3. Our y momentum is going to be the momentum of the second, which is only in the y direction, so that's just 4 times 1. So we have momentum that is, I actually have this backwards, but it's the same answer either way. It should be 4 and 3, but either way, the resultant of those two is 5, so that's the resultant momentum.